Hello everyone, welcome to our presentation about a pioneer of SDN and NFV, China Unicom and World Cloud. I was inspired to use this photo on my title slide after seeing the long list of the other OpenStack SDN NFV attendees, the pioneers who were assembled here in Paris. If you're not familiar with the photo, it's from the 1927, the 5th Survey International Conference on Electrons and Photons, which was held only 300 kilometers away in Brussels. Thank you. It's one of the most famous scientific conference ever. The 29 attendees, including 17 eventual Nobel Prize winners, and among them were the legendary Albert Einstein, Marie Curie, Niels Bohr, and Max Planck. Oops. I think.
It's looking in the wrong direction.
Yeah, sorry, I clicked this. Yeah, sorry. The definition of a pioneer is someone who's the first to use or apply a new method, area of knowledge, or activity. This presentation is the first of our NFV and SDN series, case studies about the first to deploy service-centric open networks. The presentation also represents our intention to expand our SDN evangelism beyond technology and architecture to real deployment. The subject of our case study is China Unicom and their World Cloud Data Center as a Service. This is the World Cloud homepage, where you can see that data center as a service includes compute, storage, and networking cloud services. To help you grasp the scale of the project, I would like to show you the first two data centers for World Cloud infrastructure. Data Center 1 is in Langfang, China, the world's fourth largest, almost 7 million square feet, and cost an estimated $1 billion to build. Data center number 2 is in Hohhot, China, is the world's 5th largest at over 6 million square feet and cost almost $2 billion to build. But that's not all. China Unicom recently announced they are expanding their World Cloud services to a total of 10 data centers, which are now under construction throughout China in the location marked by the pinks. Together, they will allow China Unicom to deliver nationwide coverage to its 1.3 billion people, 1.2 billion cell phones, and all the traffic that comes with all those people and phones. World Cloud was formed in 2012, and SDN was introduced in 2013. These are metrics for World Cloud before the SDN backbone was deployed. CPU utilization was 5%. The number of devices managed per person was 20. And it took 2 months to deploy a network application. You will see at the end of this presentation how deployment of SDN changed these numbers. Every product starts with business requirements, and this project was no different. China Unicom knows that old ways of building networks will not allow their data center as a service to scale, and they wanted innovative new approaches to delivering value-added services to scale quickly and compete with the best in the world. They wanted the ability to deploy new technologies and services fast. They wanted extreme agility, the ability to add, delete, change services quickly, and they feel that could only be done with software. They also knew that because of the massive scale of their operation, manual operations were out of the question, and their profitability and scalability would depend heavily on automation. The technical requirement is value-added services on demand. In the past, services were tended to static tunnels with static configuration provisioning with resulting complex training and long services TTM. And because it lacked flexibility, this approach cannot meet the requirements of complex use case. For example, too many VAS devices, big difference of service requirements. But with a virtual networking pool, services are provisioned when and where needed. VAS nodes can be created and deleted on demand based on various service requirements for tailored VAS routing. A centralized controller indicates network forwarding policy based on the VAS routing to achieve automatic joining and automatic configuration of VAS device policy. With a set of business and technical requirements, the architecture team was inspired to set a course for world cloud. This direction is their vision state, and it's very simple. Build the world's best data center as a service. The team also created a mission statement which defined how to get there. It consists of 4 points. Number 1, deliver customers-driven services. Number 2, implement well-defined and standardized process. Number 3, deploy one platform for cloud hosting and cloud storage services. Number 4, build on a service-centric open networking SIAM foundation. Give me 1 second. The slide seems in the cloud. Okay, here we go. As I mentioned, the foundation of the world cloud architecture is SIAM. We found there were a couple of common definitions for the word. SIAM is the young shoot or twig of a plant, cut for growing and rooting for new growth. SIAM can also mean a descendant of a notable family. Using the word in a sentence, you might describe Paris Hilton by saying she was the scion of a wealthy family. The definition have an interesting analogy in our world of service-centric open networking. Now let's look at a more technical view of a service-centric open networking model. The top layer faces the logic network. Programming logics resides here, and it is at this layer that you can dynamically create, enable, and disable services without changes to physical infrastructure. The next layer down is the network resource abstraction layer. This layer virtualizes the network resources. Network resources in multiple DCs can be integrated into one unified network resources. The third layer down is the controller layer, where you can find mechanisms that provide abstraction capabilities to application. It is the layer that provides centralized control of the network. The bottom layer is where you can find network infrastructure and the elements. Working together, they deliver programmable on-demand networks. When you stack these capabilities together, you see the big picture of how network resources are combined to match the needs of each application, and how the controller, hypervisor, network, and OS abstract the network resources and opens to the application hierarchically. This is a view of a SUPA architecture in the context of a service-centric open network. The SUPA layer includes service modeling to create data models such as L2 VPN, L3 VPN, and traffic steering. The modeling includes a service intent model and a service configuration model. Network modeling to create abstracted network infrastructure and corresponding network data models. the ability to compile the data structures of service models and network models, which is needed to configure the network element. SUPA also includes the ability to mapping the network model configuration to the network elements configuration. This is the world cloud architecture, which integrates 4 main concepts: cloud computing, SDN, SIAN, and SUPA, the shared unified policy automation. Regarding the scalability, we have 8,000 virtual machines, 500 servers, 20 developers, and 5 of them to do the maintenance at the same time. What we would like to do now is to summarize the key points and share some key lessons learned. First, Huawei SIAN is the foundation of the open, scalable world cloud network. The automation of cloud service deployment and automapping the configuration of service into network configuration now reflects the requirements of services in the network forwarding behavior. The second summary is world cloud integration with Neutron gives cloud tenants an API to build rich networking technologies and configure advanced network policies in the cloud. Today, SDN is fully implemented as the results are very positive. The last 2 slides are just 2 simple lessons we would like to share with our peers. First, the full virtualization is required to achieve the capability to support millions of servers in multiple data centers and heterogeneous application environment. The IT infrastructure resources, for example, server, storage, network, and security device used in the world cloud platform are fully virtualized. And last, hyperscale resource management is needed. Thank you very much for attending our presentation. If any of you have questions or comments, feel free to contact us at chenjingjing@chinaunicom.cn and tina.zhou.zhouting@huawei.com. Thank you.